The history of our planet is an astonishing journey, spanning over 4.5 billion years, marked by incredible transformations, collisions, life forms, and periods of both creation and destruction. It's a tale of resilience and survival amidst a constantly changing environment, one that has been shaped by cosmic forces, geological upheavals, and, eventually, the rise of complex life. To take a whirlwind tour through Earth's history is to trace the steps of not just our species but of the planet itself, starting at the very beginning of our solar system's formation. About 4.5 billion years ago, our solar system began to emerge from a vast, dense cloud of interstellar gas and dust. This nebula was likely the remnants of a previous star that had gone supernova. As gravity caused this cloud to collapse, it formed a swirling disk of matter that spun faster and faster, heating up as it contracted. At the center of this spinning disk, temperatures rose high enough for nuclear fusion to ignite, transforming hydrogen into helium and giving birth to our Sun. This was the moment our solar system took its first steps toward becoming the dynamic, life-bearing system we know today. Simultaneously, the material on the outer edges of this disk began to coalesce into clumps. These clumps would become the seeds of planets, moons, asteroids, and other celestial bodies. In the cooler regions farther from the Sun, the material was composed primarily of ice, gases, and liquids, leading to the formation of gas giants like Jupiter and Saturn. Closer to the Sun, where the temperatures were higher, the rocky material formed the terrestrial planets, including Earth. This was the beginning of the formation of our home, though at this stage, it was a very different place from what we recognize today. Earth was a volatile and molten world, with its surface being shaped by constant volcanic activity and a relentless barrage of asteroids and comets. As Earth grew, its gravity pulled in more and more material from the surrounding space, gradually increasing its mass and becoming more spherical in shape. This early Earth was incredibly hostile, with its surface covered in magma and its atmosphere thick with gases like hydrogen sulfide, methane, and carbon dioxide, spewed out by countless volcanic eruptions. This was Earth's first atmosphere, an unbreathable mixture for any life as we know it today. However, this atmosphere would play a crucial role in the planet's future, setting the stage for the development of more complex chemical processes that would one day lead to life. During this tumultuous period, Earth experienced a cataclysmic event that would change its destiny forever. Around 4.5 billion years ago, a Mars-sized planet named Theia collided with the young Earth in a massive impact. The force of the collision was so great that it blasted huge chunks of Earth's mantle into space. Over time, these fragments coalesced under the influence of gravity to form Earth's only natural satellite, the Moon. The formation of the Moon was not just a spectacular event in Earth's history, it had profound consequences for the development of life. The Moon stabilized Earth's axial tilt, which in turn stabilized the planet's climate over long periods, creating more favorable conditions for the future evolution of life. As Earth continued to cool, the surface gradually solidified, and the planet's first crust began to form. At the same time, water, which had been locked in the form of vapor due to the extreme heat, began to condense as the planet's temperature dropped. Around 3.8 billion years ago, the first primitive ocean formed, covering much of the young planet in water. This was a pivotal moment in Earth's history because water is an essential ingredient for life. The formation of liquid water provided the necessary environment for the chemical reactions that would lead to the emergence of the first living organisms. Life on Earth began around 3.7 billion years ago, and it was incredibly simple at first, consisting of microscopic, single-celled organisms. These early forms of life, known as prokaryotes, were incredibly resilient and adapted to the extreme conditions of the time. They thrived in environments that would be inhospitable to most modern organisms, such as the deep oceans and hydrothermal vents. For nearly a billion years, life remained microscopic and relatively simple. But even in this early stage, life began to alter the planet in significant ways. One of the most important developments in Earth's history occurred around 2.4 billion years ago when a group of bacteria called cyanobacteria evolved the ability to perform photosynthesis. This process, which uses sunlight to convert carbon dioxide and water into sugars and oxygen, began to release large amounts of oxygen into Earth's atmosphere. Before this, the atmosphere had been largely devoid of oxygen, but over millions of years, the activity of these photosynthesizing organisms gradually transformed it. This event, known as the Great Oxygenation Event, was both a blessing and a curse. While it created conditions that would eventually support complex life, it also caused a mass extinction of anaerobic organisms that could not survive in the presence of oxygen. With the increase in atmospheric oxygen, the planet's climate began to change. The higher levels of oxygen contributed to a significant drop in carbon dioxide levels, which in turn caused the Earth to enter its first major ice age. For a period, much of the planet was covered in ice, a phenomenon known as snowball Earth. This global glaciation may have lasted for hundreds of millions of years, but eventually, volcanic activity released enough greenhouse gases to warm the planet and melt the ice. This thawing paved the way for new forms of life to emerge and thrive in the oceans. As Earth's atmosphere and climate continued to evolve, so too did its land masses. The first continents, known as cratons, began to rise above the ancient oceans around 3.3 billion years ago. These cratons were the building blocks of Earth's future continents. Over time, they would drift and collide with one another, forming larger landmasses and, eventually, supercontinents. The first of these supercontinents was Valbara, which formed around 3.1 billion years ago. Although it was much smaller than modern continents, Valbara set the stage for the future assembly of larger landmasses. One of the most significant periods in Earth's geological history occurred around 1.1 billion years ago when the supercontinent Rodinia formed. Rodinia was vast, possibly the largest supercontinent to ever exist on Earth. It included most of the landmasses that we recognize today, but they were arranged in a completely different configuration. Rodinia's formation marked the beginning of a long period of geological stability, during which life continued to evolve and diversify. Life on Earth took a major leap forward during the Cambrian explosion, which occurred between 540 and 485 million years ago. This was a time of rapid evolutionary change, when many new types of organisms appeared, including the first animals with hard body parts such as shells and spines. The most famous of these early animals were the trilobites, which dominated the oceans for millions of years. The Cambrian explosion was a turning point in the history of life on Earth, as it marked the beginning of the diversification of complex life forms. However, the history of life on Earth has been punctuated by several mass extinction events, the first of which occurred around 440 million years ago during the Ordovician-Silurian extinction. This event was triggered by dramatic changes in the Earth's climate, which caused the temperature of the oceans to fluctuate rapidly. As a result, many marine species were wiped out, including a significant number of the organisms that had emerged during the Cambrian explosion. This was the first of many extinction events that would shape the course of evolution on our planet. Despite these setbacks, life continued to evolve and adapt. Around 420 to 350 million years ago, the first plants began to take root on land, followed by the first animals. These early land plants were simple, but they paved the way for the evolution of more complex ecosystems. Meanwhile, the continents continued to drift and collide, forming new landmasses and reshaping the Earth's surface. Around 250 million years ago, the Earth's continents came together to form the supercontinent Pangaea. This was the last time in Earth's history that all of the landmasses were joined together in a single supercontinent. Pangaea was surrounded by a vast ocean, and its formation had a significant impact on the planet's climate and ecosystems. Unfortunately, it was also during this time that Earth experienced the most devastating mass extinction event in its history, the Permian-Triassic extinction, also known as the Great Dying. This event wiped out approximately 90% of all species on Earth, including many marine and terrestrial organisms. The Great Dying cleared the way for a new era in Earth's history, one that would be dominated by the dinosaurs. The first dinosaurs appeared around 240 to 230 million years ago, and for the next 150 million years, they ruled the land. Some of the most iconic dinosaurs, such as the massive Argentinosaurus and the fearsome Tyrannosaurus rex, roamed the Earth during this time. The breakup of Pangaea during the Jurassic and Cretaceous periods created new habitats for these creatures, allowing them to diversify and thrive. However, the reign of the dinosaurs came to an abrupt end 66 million years ago when a massive asteroid struck the Earth near what is now the Yucatan Peninsula in Mexico. The impact caused widespread devastation, sending debris into the atmosphere and blocking out the sun. This led to a dramatic cooling of the planet and the extinction of the dinosaurs, along with many other species. In the aftermath of this extinction event, mammals, which had previously been small and relatively inconspicuous, began to rise to prominence. Over the next 60 million years, mammals diversified and evolved into a wide variety of forms. Some, like the ancestors of modern primates, began to exhibit traits that would eventually lead to the evolution of humans. The earliest known human ancestors appeared around 6 million years ago, and they were very different from modern humans. These early hominins, such as Sahelanthropus, likely still walked on all fours and had small brains compared to modern humans. However, around 4 million years ago, some of these early humans began to walk upright, a key development in the evolution of our species. The ability to walk on two legs allowed early humans to explore new environments and use their hands for tasks such as making tools. About 3 million years ago, early humans began to use simple tools, such as stones, to break open bones and extract marrow. This marked the beginning of a long tradition of tool use that would become increasingly sophisticated over time. Around 800,000 years ago, early humans discovered how to control fire, a discovery that had a profound impact on their ability to cook food, stay warm, and ward off predators. The control of fire also allowed early humans to develop more complex social structures and communication skills. Their brains continued to evolve, growing larger and more capable of abstract thought and problem solving. Over time, these early humans developed more advanced tools, created art, and began to form early civilizations. By 40,000 years ago, Homo sapiens, the species to which all modern humans belong, had emerged as the dominant species on Earth. As Homo sapiens spread across the globe, they encountered and outcompete other human species, such as the Neanderthals and Denisovans. By about 15,000 years ago, Homo sapiens were the only remaining human species on Earth. These early humans were hunter-gatherers, living in small, nomadic groups and relying on their knowledge of the natural world to survive. Around 10,000 years ago, a major shift occurred in human history, the advent of agriculture. Humans began to cultivate crops and domesticate animals, allowing them to settle in one place and form permanent communities. This marked the beginning of the Neolithic Revolution, which laid the foundation for the development of modern civilization. As humans began to build more complex societies, they developed new technologies, created written languages, and established trade networks that spanned vast distances. The pace of human progress accelerated dramatically during the Industrial Revolution, which began in the late 18th century. This period saw the invention of new machines, the rise of factories, and the development of modern economies. Human populations grew rapidly, and by 1804, the global population had reached 1 billion. The Industrial Revolution also had a profound impact on the environment, as humans began to extract and consume resources on an unprecedented scale. By the 20th century, human civilization had transformed the planet in ways that would have been unimaginable to our ancestors. Technological advancements, such as the development of electricity, the internal combustion engine, and the internet, revolutionized the way people lived and worked. However, this rapid progress came with significant environmental costs. The burning of fossil fuels, deforestation, and pollution have contributed to climate change, which now poses a serious threat to life on Earth. As the 21st century progresses, humanity faces a new challenge: how to mitigate the effects of climate change and protect the planet's biodiversity. The choices we make in the coming years will determine the future of our planet and the survival of countless species, including our own.